So yesterday, what happened? What did we learn?
Wasn't it like different triangles, like basically 69 triangle, 45, 45, 90 triangle?
So two types of triangles. One was called the 45, 45, 90, and the other one was called the 30, 60, 90. So we noticed that the 30, 60, 90 triangles, there could be tiny ones or really big ones or medium-sized ones. They're all similar. So all triangles that are 30, 60, 90 for the angles are similar to each other. Okay, so since they're similar, the side fractions are equal. So for example, on the 30, 60, 90, you don't have to write anything down yet. What was this fraction? How did the hypotenuse compare to the short leg? Yeah.
Isn't it, wasn't it like, if it was a 30, if you needed to make, if you needed another long leg, you would do short leg times 3.
Yeah, so that's this fraction.
Okay.
Good, so you're remembering correctly. Oops, that's 60, sorry. You're remembering correctly that on a 30, 60, 90, this fraction was root 3. So to get this, you needed to multiply this by root 3. Okay, what was this fraction? It was 2. So that means that the hypotenuse is just twice as big as the short leg on a 30, 60, 90. So if this is 16, that's 8. If this is 24, that's 12. Okay, so those are the formulas for the 30, 60, 90. It was hypotenuse equals short leg times 2. You don't have to write these down because they're on your note card. Long leg equals short leg times root 3. So those were the two formulas, and it comes from the fact that this fraction is 2 and this fraction is root 3. Okay, then on the 45, 45, 90, the formula was hypotenuse equals leg times root 2. Okay, so this paper today is called Geometry 8-2, Day 2. And we're going to start with number 1. So here's the triangle on number 1. And we're just supposed to find the missing sides. So any ideas for any of them? Y is 50, right? Because the hypotenuse is just twice the short leg. Everybody okay with that?
Do you want to see the other triangle?
Yeah, number 1 you could probably get away with not drawing it. Does everybody see where we got 50? You sure? Okay, so then what's the x? Yeah, Kieran? 25 times the square root of 3, because on the 30, 60, 90 triangle, the long leg is always the short leg multiplied by square root of 3. And remember, this is a really unsatisfying answer, because it doesn't seem like an answer, right? But the reason we leave it like that is the square root of 3 is some nasty number. If we multiplied that by 25, we'd get some nasty number. So we'd rather not deal with a decimal that fills up the entire screen. So we just leave it like this. It's not satisfying, but it's better than the alternative, which is a decimal that's like 10 digits long. Actually, it's forever long, technically. But. Okay, everybody okay with these two numbers? All right. So now I'm going to skip to number 4. And number 4, there's this triangle. So which type of triangle is this? Yes, sir?
45, 45,
The 45, 45, 90, right? Okay, so we're not going to use these formulas. These formulas are for the 30, 60, 90. Instead, we're going to use this one. Okay, so since it's a 45, 45, 90, the hypotenuse is always the leg multiplied by the square root of 2. Which side did they give us? They gave us the hypotenuse, right? Because the 9 is across from the 90. So that means the 9 goes in for h. So this is the template, the formula, the thing that goes with 45, 45, 90. But then on this particular 45, 45, 90, the 9 is the hypotenuse, so that's why I replaced h with 9. And then I just recopied everything else. I'm trying to find x. So I need to get x by itself. What's preventing x from being by itself? The root 2, right? So how do I get rid of the root 2? If there's multiplication here, how do you get rid of multiplication? You divide, right? Because division undoes multiplication. So we need to divide to get rid of the multiplication. Since it's multiplied by root 2, we need to divide by root 2. And we do that on both sides because it's an equation, and that's how equations go. So then root 2 divided by root 2 crosses out. So this side is just x. And then on this side, we get 9 divided by root 2. So we have the correct answer now. If you took 9 divided by root 2, you would get the correct number for this side of the triangle. But there's something that we don't like about this. What don't we like about this? It's got a square root in the denominator. So on Tuesday, before the snow day, we learned that mathematicians don't like having square roots downstairs. So we have to fix that. It's called rationalizing the denominator. All right, so how do I fix that? What do I do to 9 divided by root 2 to get rid of the square root in the denominator? Yeah. Good. So you multiply by root 2 over root 2. And don't forget that the reason that's legal is because this is equal to 1. And so we're really just multiplying by 1, which doesn't change anything. It changes what it looks like, but it doesn't change what it's worth. So the top comes out to 9 times root 2. The bottom comes out to root 4. And then root 4 is 2. So we get 9 root 2 divided by 2. So that's the length of this side of the triangle. 9 root 2 divided by 2. Okay, then what's the length of this side? This side's 9 root 2 divided by 2. What's this side? It's the same thing, right? Because on a 45, 45, 90, the two legs are equal. It's an isosceles triangle. the 45, 45, 90 triangle, it has two equal angles. So it also has two equal sides. It's isosceles. So this side is also 9 root 2 divided by 2. All right, now we're going to go to 7. In number 7, it says an altitude of an equilateral triangle is 8.3 meters. An altitude of an equilateral triangle is 8.3 meters. And the question is asking us to find the perimeter of the triangle. So what's an equilateral triangle? Yeah, Charlie?
3 equal sides.
Has 3 equal sides, right? Equilateral means equal sides. So let's draw that triangle. Here's a triangle that's equilateral, has 3 equal sides. Since it has 3 equal sides, it's also going to have 3 equal angles. So that means all the angles are 60, because 60 plus 60 plus 60 is 180. So I'm going to label this one 60, and I'm also going to label this one 60. I'm not going to label the top one. You'll see why in a minute. It's 60 also. All right, now it's talking about the altitude of the triangle. Altitude is a fancy word for height. So I'm going to draw in the height. The height goes from the top straight down to the bottom. And when I say straight down, I mean it makes a 90. So there's the altitude of the triangle. Apparently it's 8.3. So I'll label it 8.3. Okay, now the reason this is coming up on today is because now we have a smaller triangle over there on the left. There's 3 triangles in this picture. There's the large one, the equilateral. There's that one, and then there's the other one that I'm covering up. Okay, so now let's focus on that smaller triangle. What kind of a triangle is that? It's got a 90, it's got a 60, so that's a 30, right? Subtracting from 180. So when I drew the altitude, it ends up that that is 30 up there. So that's why this is happening today, because that's now a 30, 60, 90 triangle. So we can use our facts about 30, 60, 90s to figure stuff out. All right, so the 8.3, is that the hypotenuse? No, it's not, because it's not across from the 90, right? The hypotenuse is over here. So it's one of the legs. Is it the short leg or the longer leg? It's the long leg because it's across from 60. The shorter leg would be across from 30. So 8.3 is the long leg. Okay, so one of the formulas for 30, 60, 90 is long leg equals short leg times root 3. This is just one of the facts that's true about 30, 60, 90s. On this particular 30, 60, 90, the long leg is 8.3. So I'm going to replace LL with 8.3. So this is the general formula, but then on this particular triangle, I was able to put 8.3 in for long leg. All right, so I'm trying to figure out the short leg. So I'm going to divide by the square root of 3. That'll cross this out. So I'll just have short leg equals 8.3 divided by the square root of 3. Thanks. Okay, now we don't really like it when the square root's in the denominator, but we're going to fix that later. Okay, so that means this right here, the distance here, is 8.3 divided by square root of 3. So then how far is it from here to here? Yeah.
8.3 divided by the square root of 3 times 2.
Well, that's how far it is from here all the way to there. But from here to here, it's just 8.3 divided by the square root of 3. But yeah, you have the right idea. Okay, so that's 8.3 divided by the square root of 3. And so what he was saying was from here to here is 8.3 divided by the square root of 3 plus itself. So this adds up to 16.6 divided by the square root of 3. Because you just add the tops and then you have a common denominator. So that means the distance from there to there is 16.6 divided by root 3. So then how far is it from here to here? Same thing, right? Because this is an equilateral triangle. So that side is 16.6 divided by square root of 3. And then this side is 16.6 divided by the square root of 3. All three of them are the same because it's equilateral. Okay, so then the question is asking, what is the perimeter of the triangle? So to find perimeter, you have to add up the distance all the way around the outside. So it's 16.6 divided by the square root of 3 plus another 16.6 divided by the square root of 3 plus another 16.6 divided by the square root of 3. We're just finding the perimeter, so we're adding up all three sides. So when you add fractions, you just keep the common denominator. And then you add the top number. So 16.6 plus 16.6 plus 16.6. That comes out to 49.8. So this is my perimeter. And if you get this as your answer, you have the correct answer. You have the correct number. But we don't like this as a final answer because it's got a root 3 in the denominator. So we have to do what's called rationalizing. So we multiply that by root 3 over root 3 to get rid of the square root in the denominator. So that's 49.8 root 3 on top. Just multiplying across. And then root 3 times root 3 is root 9. And then root 9 is 3. And then 49.8 divided by 3 is 16.6. So that's your final answer for your perimeter. The distance around the equilateral triangle.
I'm also kind of useless because like we had 16.6 divided by square root of 3.
Yeah, it's just a cool, I mean, we added it up 3 times,
Yeah.
and then we divided by 3, so of course we're back where we started, right?
Yeah.